Welcome, ladies and gentlemen. Today we're going to be talking about the Algebra 1 EOC, and we're going to be looking at questions from reporting category number 2 from the 2017, 2018, and 2019 versions of the Algebra 1 EOC. And in this video, I'm going to be going over all the questions from the 2017 version of the EOC. But first, I want to go over some big calculator tips for this particular reporting category. And the first thing I want to look at is this right here. A lot of students really struggle with where to start in a problem. If the problem contains f of x equals or y equals, this first strategy is to plug the equation into your calculator, then go from there. So if you have no idea what to do, that's a really good starting point. If you have f of x equals, which is just fancy schmancy for y, right? F of x means y, then plug it into your calculator into y equals and go from there. If you have answer choices that have y equals in them, you can do that as well. The next big strategy that I like to say is if the problem contains a table of values or 2 points, plug the information into stat and perform a linear regression. So how do we do that? How do we plug in information into our stats? So the first thing we're going to do is if I'm given 2 points or if I'm given a table of values, I have to enter in that data into my calculator. How do I do that? I click on stat and then edit, which means it's just enter. So stat edit is just stat enter. You enter your x values into L1, that's list 1, and it'll look like this. L1, L2. Enter your x values here and then your y values here. So you always want to make sure that you have the same number of x values that you do y values. If you don't, it'll say error. So then the next thing we're going to do is to actually perform the linear regression. So if one of the things I tell my students, if I'm in stat, I stay in stat. So I've got data entered into stats, into L1 and L2. Now I want to perform a linear regression. So I go back into stat. And in this case, I have to arrow right to calc so that calc is highlighted. And then I go all the way down to when I see linreg. That's linear regression in the form of ax plus b. And then I press enter, and I keep pressing enter until the equation shows up on my screen. A represents the slope, which you're probably used to seeing y equals mx plus b. On your calculator, the slope is going to be a. So A is the slope, B is the y-intercept, our beginning point where it crosses the y-axis, and y equals ax plus b is the same thing as y equals mx plus b. So if you're given a table of values or 2 points, you're able to find the slope using this method, the y-intercept using this method, and the equation of the line using this method. This is also good when you're finding the line of best fit. The line of best fit, you're still going to enter in the data into stat, and you're still going to do stat, calc, linreg, but sometimes questions in this category ask for a correlation coefficient. So we need to turn on our diagnostics. How do I do that? Well, it's right here in the catalog. That's in blue on this calculator. If you have a TI-83, it's in yellow. So it's in blue, which means it's a second function. So I need to press second first, then I press the button 0. That goes into our catalog. Go all the way down to diagnostics and turn on diagnostic on. Press enter until it says done. Then what you'll see when you do your linear regression is you'll see this R value. And it'll be some number, some decimal, okay? And that's your correlation coefficient. So there are questions in this category that ask for that. It's really easy if you know how to do this, and if you just remember the R value is your correlation coefficient. There's always one question. So let's get started. Okay, question number 1. Which graph best represents the solution set of y is less than or equal to negative 4x? Awesome. Y is already solved for. I don't have to solve for y. But let's see what this inequality tells me. It's less than or equal to, there's that line underneath my inequality. That tells me that we're looking for a solid line. So can I eliminate any answer choices? Sure, I can eliminate A and B. And then now, if I really don't know what this inequality is telling me, but y is solved for, I can always plug in y equals negative 4x on my calculator and see what it looks like. It's obviously not a horizontal line, so it's not going to be D. Your answer is C. But if I go a step further, this particular line, because it's less than or equal to, if it's greater than, we shade above, less than, we shade below. So what I like to say is put your pencil on this line and shade down toward the less than sign. That's where we're going to shade. Another thing that we can do when we're solving. So number 9, which situation best represents causation? Okay, here's this word right here. We talk a lot about correlations whenever we are in our statistics. Causation, there is a cause and effect. Something absolutely affects something else. Okay, there is a result from something. So we talk a lot about correlations in this particular unit. Just because there's a correlation, that does not mean or does not imply causation. So even though there may be a relationship between the two things that we're talking about, one does not directly cause the other. So when we go through our answer choices, A says, when the number of bus stops increases, the number of car sales decreases. Well, there could be some kind of correlation between those two things, but one does not directly cause the other. So even though there could be a correlation, one doesn't cause the other. When fewer firefighters report to a house fire, the damage caused by the fire decreases. Well, one does not directly cause the other. C, when ice cream sales increase, incidents of sunburn increase. No, absolutely not. When it rains several inches, the water level of a lake increases. Absolutely. When it rains, the water level increases. One causes the other. So that represents causation. All right, let's go on to number 12. Now, I find this problem to be really difficult for students. So I'm going to go through this the way I think you should on your EOC. A lifeguard earns $320 per week for working 40 hours plus $12 per hour worked over 40 hours. A lifeguard can work a maximum of 60 hours per week. Which graph best represents the lifeguard's weekly earnings in dollars for working H hours over 40? Okay, so what does H represent? The number of hours worked over 40 hours. Okay, so one of the things I like to say is if you see this per, like $320 per week, $320 every week, a week, each week, that's your rate. However, we have this other phrase over here, $12 per hour. Okay, well, I'm not going to have two rates in this particular problem. So which rate is important? Let's see. In my equation, y equals mx plus b, I'm looking for, right here, my unit rate. What would my b value be? So if this lifeguard earns $320 per week, that's his base amount. So really, that's what he's going to get for working that 40 hours. Every hour worked over 40 hours, that's where he gets $12 per hour. So the question asks, which graph best represents the lifeguard's weekly earnings in dollars for working H hours over 40? So essentially in this problem, we have to assume this lifeguard has already worked a 40-hour work week, which means 320 is our beginning amount. He's already earned, or she has already earned $320. Then if we add $12 per hour, I should make that an X, worked over 40 hours, that's going to give us his weekly earnings. Okay, which one of these represents that? This is a really difficult question. Okay, so the first thing I'm going to look at is right here. That's my y-intercept, $320. Which ones can I eliminate? Well, this has a y-intercept of 0 and a y-intercept of 0. So I can eliminate H and J. So in this case, students will really struggle with this because you can't just see that my rate is 12. And remember, or my slope is 12 over 1. So what I really like to do is pick 2 points from a graph. In this case, I would pick this one right here, which I know to be 0, 320. And this point right here, which is about, and you might struggle with this a little bit, but if you're doing the same thing for these 2 problems, okay, then just kind of guesstimate. And it may not be perfect what you end up with, but whatever's closer, that's your answer. So this one right here, I'm going to pick 20,560. And I'm going to take those 2 points, I'm going to plug them into stat, L1 and L2. I'm going to plug in 20,560. I'm going to plug in 0, 320. Then I'm going to do a linear regression. And when I do that, I get that A equals 12, which means G is my answer. If I did that with F and I picked 2 points, and you know, if you picked different points besides 20,560 and 0, 320, but they were fairly close to that, you got something, or you will get something close to 12. Do the same for F, and you do not get 12, okay? You'll get something less than that. So the answer is not F, it's G. And that's the best strategy I can give you on this, what I would consider very difficult problem. Okay, let's go on to number 16. What is the slope of the line? I love these types of questions, super duper easy, but it's only easy if you can solve for y. You have to be able to solve for y. I can give you tips and strategies for different things on your EOC, but you have to be able to solve for y. So how do I do that? Minus 5x minus 5x. So now I'm going to rewrite it. Negative 12y equals negative 5x plus 24. And why do I write that x term first? Because I'm putting it in slope-intercept form. And now what do? Divide by negative 12. And then what gets divided by 12? Negative 12, sorry. Everything gets divided by negative 12. Negative 5 divided by negative 12 is positive 5/12. Then 24 divided by negative 12 is negative 2. The number in front of the x is my slope. That's my M value. J is your answer. All right, we are rocking and rolling. Let's go on to number 19. The table shows the heights and the lengths of several rectangles. Whew. What does this is what I was talking about. What does the correlation coefficient for the data indicate about the strength of the linear association between the height and the length of these rectangles? So again, this is that correlation coefficient I was telling you about. You want to make sure that you turn on your diagnostics. Okay, you'll find this in the catalog. Go all the way to diagnostic on, press enter until it says done. So you're going to take this data, height you're going to plug into X, length you're going to plug into Y, or I should say L1 and L2. So you're going to plug this information into stat. And if you want to pause the video and go ahead and do that now, it would be a good time to do that. So then the last thing that you're going to do is you're going to perform a linear regression. So how do we do that? We go to stat, scroll over to calc, so make sure it's highlighted. Then you're going to scroll down to linreg, or linear regression, AX plus B. Press enter all the way until your equation shows up. Your correlation coefficient is the R value. That's what you need to remember. You're looking for the R value. In this case, it is a very low number between 0 and 1, which shows that it is a weak positive correlation. And if you may need a little lesson over correlation coefficients. This will probably be, if there is one, only one question on your EOC from it, but it's really easy to get the question correct. Sometimes the question asks, what is the correlation coefficient and what does it mean? If it's between 0 and 1, it's a positive correlation. Okay, so obviously the number was positive, the R value, which means I could eliminate those two answer choices. And any number between 0 and -1 shows a negative correlation. So the closer to 0, the weaker the correlation. The closer to 1 or -1, the stronger the correlation. Okay, let's go on to number 26. The graph models the linear relationship between the temperature of Earth's atmosphere and the altitude above sea level. Which of these best represents the rate of change of the temperature with respect to altitude? So anytime you see rate of change, I want you to write the word slope above it. That's all that means. What's the slope of this? All right, well, let's pick 2 points. 2 points that I would like to pick would be right here. What could we do? 7 right here. 7 -30. That would be a good point. So 7 -30. And what about this one right here? 4 -10. So notice I picked 2 points where I can see that it crosses, like it intersects two integers. Okay, so I didn't pick like this point right here. Well, I just really don't know what that is. I picked 7 -30 and 4 -10. And then if I'm using my test taking strategy, I'm going to plug these 2 points into stat because that's my strategy. Okay, you can always do the algebra for it and use your slope formula, plug it into y, or just use your slope formula, and then you'll end up getting F. But I'm just kind of teaching you some test taking strategies, so you can plug it into stats, L1, L2, 7 -30, 4 -10, stat calculin reg, boom, there you go. A equals -6.5, and that's what it'll give you. Or actually, I'm sorry, in this particular problem, I picked 2 points, and I got that A is actually -6.67, which the closest answer to this is F. So in these types of problems, maybe, just maybe, these 2 points that I picked weren't exact. So, but that one is the closest. F is the closest to the slope that I got. So that's going to be my answer. Okay, let's move on to number 29. I should probably go a little bit quicker through this. Number 29, the line graphed on the grid represents the first of 2 equations in a system of linear equations. If the graph of the second equation in the system passes through the points -12, 20, okay, well, let's graph this. -12, 20 would be right there. And for 12, which statement is true? Well, in this case, what happens? Oh my gosh, my line is terrible. But what happens if those 2 lines are graphed, which, you know, on your EOC, you're going to have paper and pencil, and you can absolutely put a straight edge up to those points, and you can see that these 2 lines are parallel. So if you really want, though, you could also do your slope formula for these 2 points. Figure out the slope. Pick 2 points on your other line, do the slope formula, or draw your triangle on your graph. And you'll see that these 2 lines have the same slope, which means they're parallel. So when I think of a system of linear equations, the solution to a system is the point at which the lines intersect. If they never intersect, what's my solution? No solution. They're never going to intersect. There's no solution. Moving on to number 32. The graph of a function is shown on the grid. Which ordered pair best represents the location of the y-intercept? Okay, here's my y-axis. So wherever it crosses this y-axis is my y-intercept. Right here, well, what ordered pair is that? 0, -2. Okay, the y-intercept is when x is 0. So my x value is 0, y value is -2. All right, moving on. Let's go to number 37. Which ordered pair is in the solution set of y is greater than or equal to 1/3 x plus 4? So one of the things you can do is, if you don't recall inequalities, anytime you see y equals, you can plug it into y equals. So you can at least plug this into y equals on your calculator and see what it looks like. Okay, I'm going to have a positive slope. Now, if I graph this on my coordinate plane, I'm going to graph my y-intercept first at +4, and then my slope is 1/3. So I'm going to, from this point, from this beginning point, I'm going to rise 1 and run 3. Rise 1, 1, 2, 3. Rise 1, 1, 2, 3. And I can also go down 1, 1, 2, 3 to the left. Down 1, 1, 2, 3 to the right. And all those points still fall on the same line. Because it's greater than or equal to, my line is going to be solid. And in an inequality, I like to put a greater than at top, less than down below. Anything greater than or equal to this line, put my pencil on the line and go up. Any point up here is in the solution or on the solid line. So which of these is actually in that shaded region? Your answer is B. -1, 6, if I were to graph this, is right up here. That's in the shaded region. And it's important to remember, if it's on the solid line, it's a solution. If it's on the dotted line, if the line were dotted, is it a solution? No, not a solution. So there you go. And also, because ordered pairs are x, y, if I plug in -1 for x and 6 for y, in y is greater than or equal to 1/3 x plus 4, I'll end up with a true statement. It will be true. What's on the left over here will be greater than or equal to what's on the right. Moving on to 42. The graph of linear function g is shown on the grid. What is the 0? Okay, well, what does 0 mean? Academic vocabulary, you have to know what this means. It means x-intercept. If it asks for 0 or root or solution, that's x-intercept. So what is the x-intercept? Easy peasy, -6. Okay, how do I bubble that in on my recording document? -6, positive here, negative here, bubble in -6. All right, moving on to 45. A student graph f of x equals x, that's fancy smancy for y, you can plug it into y equals, and g of x equals f of x plus 3. Okay, g of x, that also equals y. Well, this f of x plus 3, that's kind of difficult, right? You have to remember your notations. What does that mean? Well, if f of x is x, and g of x is f of x plus 3, then g of x is x plus 3. So I can graph these two in my calculator. y1 equals x, y2 is going to equal x plus 3. And what happens? A, the graph of f is shifted 3 units up to create the graph of g. So this is just function notation and how we look at transformations. It's really a simple question, but a lot of students really struggle with what the question is asking them to find and just interpreting the wording of it and the notations. That's what's difficult with this problem. Okay, number 52. The function y equals 3.75 plus 1.5 times x minus 1 can be used to determine the cost in dollars for a taxi ride of x miles. What is the rate of change, slope, of the cost in dollars with respect to the number of miles? Okay, I really like y equals mx plus b. So what we're going to do is we're going to convert this to slope-intercept form. So y is already solved for. I'm just going to make it look mx plus b. Y equals mx plus b. So I'm going to distribute this 1.5. So 3.75 plus 1.5x minus 1.5. And then what do I need to do at this point? Combine like terms. So I'm going to put this in slope-intercept form. So this number with the x term attached to it, I'm going to write that first. And then 3.75 minus 1.5 is 2.25. The question's asking me to find the slope. That's the number in front of the x, which is $1.50 per mile. And that concludes your just review over all the questions from the 2017 version of the Algebra 1 EOC for reporting category number 2. I hope it was helpful.